Alright, students, so when we're talking about divergent plate boundaries, we can actually understand based upon the image, the visual on the screen, the molten materials rise and simply spread out in different directions away from each other, resulting in the surface plates to move away and diverge. Alright. Now, if you look carefully on your screen, you can actually observe that these plates are in fact the opposite of convergent plate boundaries. Alright, they are totally the opposite. However, if I were to tell you that these plates simply move away from each other in the opposite direction, we must keep in mind that these particular plates technically will actually create a gap on the surface of the Earth. Or it could actually be these plates can actually be diverging basically below the oceans. Okay. Now, with respect to the oceans, right? If you look carefully on the screen, you can actually see the arrows at the surface referring to the directional part of these plates. At the bottom, this arrow, which is bulging up, technically is in fact molten materials from the depths of the mantle, rising up and filling in the gap that is actually created as the plates move away from each other. All right. There is in fact a reason for this. Right, these oceanic crust below the oceans themselves, they are very thin. So as the plates simply move away from each other, there is not much of a thickness for the molten materials to spread. It will actually breach the surface very quickly, and it interacts with the surrounding water, right, which eventually cools the molten material, allowing it to solidify to form different features. So divergent plate boundaries are in fact associated with a number of features, and we know fully well these features are, two of them are very much similar to that of convergent. All right, we have, first and foremost, we have suboceanic volcanoes. These are in fact volcanoes which are situated primarily below the oceans, as a matter of fact, and they basically emit a lot of gases and molten materials would rise. All right, so suboceanic volcanoes are in fact one of the few examples that we have that are associated with divergent plate boundaries. Students, secondly, we also have what you call volcanic island arcs. Because if you look at this carefully, this actual example here shows the North American plate moving away from the Eurasian plate. This will create molten materials to rise. If that happens over a period of time, right, the molten materials solidify to create new land. And what happens there is that it creates a landform because of hardened rock structures created by the cooling of the molten materials. All right. So we also have volcanic island arcs. Remember, an arc is in fact a chain of islands. So technically, divergent plate boundaries, we can have a chain of volcanically created islands, what we call volcanic island arcs. We will talk about this example just now. And thirdly, if you look at the actual image on the screen, you can actually see this is an area where you have a ridge. A ridge is actually a very distinctive peak. Yes, most of them can actually exist below the oceans, similar to like a mountain peak, except these divergent plate boundaries are associated with technically below the ocean bed, at the seafloor rather. And what happened is that in many instances, right, it forms a very distinctive peak as such, primarily because of the upsurge of molten materials which spread on the surface. Okay, so keep that in mind for me. Now, at the bottom of this particular diagram, we can actually see a constructive or divergent plate margin. Remember what we said earlier, a margin is also known as a boundary. All right. Now, that being said, divergent plate boundaries, since they do not possess any form of subduction, we should know fully well that these types of plate boundaries technically are associated with land formation and are termed as constructive plate boundaries. All right, now students, looking at this particular planet Earth here, right, we can actually see that there are in fact multiple examples of where we have divergent plate boundaries. To be specific, one of the most distinctive area in the world, right, which is associated with diverging plates is technically in the middle of the Atlantic. This is in fact the Atlantic Ocean, which exists between the Americas and Europe and Africa. This is a very broad stretch where there are in fact numerous divergent plate boundary features found in the middle of the Atlantic Ocean. All right, so coming back to this particular image on your screen here, right, you would have actually seen this particular diagram showing there is in fact a great body of water. All right, we have molten materials exiting through obviously a volcanic vent. These are what you call submarine volcanoes. All right, submarine. Why? Because they exist below the oceans, the ocean level. All right, and the fact of the matter is that students, these volcanoes are typically associated with what you call basic lava because the molten materials tend to be very runny. It spreads out. All right, it is not as acidic. It is not as explosive. All right, these types of volcanoes are more mild in terms of the eruption. All right. Remember I said that they are not associated with destructive. As a matter of fact, divergent plate boundaries are said to be constructive plate boundaries. So the molten materials spread out at the bottom of the seafloor. And as you can see, this image here, it shows different layers. All right, different layers of molten material which may have spread over the successive years, decades, or whatever the case it may be. And these layers, all right, these are associated with successive eruptions. So keep that in mind for me, please, because the landform, which is situated here at the bottom of the seafloor, right, is actually created because of a process known as seafloor spreading, where you actually have molten materials exiting the volcanic vent or exiting the surface at a divergent plate boundary and simply spreading along the base, right, of the ocean, or technically spreading along the seabed. All right, that's why I call seafloor spreading. Now, students, listen carefully to this one, right? The weight of the ocean will simply compress the molten materials. But at the same time, this type of molten material is very fluid, very runny, and it spreads along this particular seafloor, eventually building up with each successive eruption. Now, a little fun fact, right, to note is that many instances you would have actually heard that areas such as the Bermuda Triangle was actually was associated with planes and ships going missing and whatnot, right? Now, just remember, students, when you have molten materials from the mantle exiting onto the surface, there will also be an interference when it comes to the magnetism. All right, students, this image shows something very, very important. As a matter of fact, this particular vessel is sinking. And the reason for that is because an object is allowed to float, like this one, on a denser medium. So that means the ocean is essentially denser than this ship. Hence, it is actually able to keep the ship afloat. But if you have gases being emitted from these volcanic vents, and these gases, obviously air will create a lighter medium, right? Air will enhance the buoyancy, right, of the particular water, right? It will actually result in the density of that particular medium or body of water to decrease. As the density of the water diminishes, right, that means it would not necessarily be able to uphold the weight of the overhead object. Hence the reason why this particular ship will tend to decrease. All right, and it actually tend to decline. Sorry, not decrease. It will decline. It will actually sink to the bottom of the seabed. All right, so this is actually a very interesting thing. Now, students, if we were to simply look at you will always hear the Bermuda Triangle, and you always wonder where it is. All right, this Bermuda Triangle is situated in the Atlantic as well. All right, in a region here. All right, however, it encapsulates a very large section, not only that particular point, but it's a very large section as a matter of fact, right? And the molten materials being spewed, right, from the Atlantic's depth, all right, is one of the reasons why many ships and whatnot can actually be negatively affected. All right, also planes are subjected to, many of them have actually crashed in the past, and many scientists believe it is because of the magnetic influences of the volcanoes rather, at the bottom of the Atlantic Ocean, which may have interfered with the telemetry of these planes. Okay. Now, apart from volcanoes, we also have volcanic islands. And a very significant volcanic island, or a group of islands, technically an arc, is what you call the Ascension Island, or Ascension Islands, as a matter of fact. And that is situated in the Atlantic as well. All right, it is actually situated in the South Atlantic. All right, this is a body or a region really, which is associated with obviously it's very close to this is the MidAtlantic Ridge in the Atlantic Ocean. These islands were created because of volcanic activity at divergent plate boundaries. We'll explain that just now a little bit. All right. This is actually a zoomed in view of the one of the largest island here, which is situated in the middle of the Atlantic Ocean. Bear in mind that this particular region is in the middle of the Atlantic and it's actually susceptible to a lot of low pressure systems and hurricanes and whatnot, which may emanate or develop from the Atlantic, as a matter of fact. All right, back to this particular this diagram on the screen. Remember we said that we talked about a ridge, a very distinctive ridge earlier, and we made mention that this particular ridge is like a distinctive peak. Right, in the bottom of the Atlantic Ocean, you have a very long stretch, all right, of ridges. And this whole region, this whole feature, which is situated at the bottom of the Atlantic, in the middle of the Atlantic, all right, is actually what you call the Mid-Atlantic Ridge. All right, and the Mid-Atlantic Ridge is actually not only one particular spot, it's actually a whole big region. Although the image shows a point in the middle, but bear in mind, students, the Mid-Atlantic Ridge actually starts from here, right, between North America and between Europe, which is the middle. If you look at this jagged line, all right, this is the ridge which exists here. Follow my cursor. All right, this is the ridge which basically exists. And look at the dimension of it. It is actually moving all the way down, extending from the northern hemisphere, straight down, all right, through the equator, straight down to the southern hemisphere, as a matter of fact, is a very huge area. It's a huge underwater ridge, which is actually called the Mid-Atlantic Ridge. Right? Why is it called the Mid-Atlantic Ridge? Because it is situated, it is in fact a ridge, which is an elevated structure which exists within or below the Atlantic Ocean, in the middle of the Atlantic Ocean. All right, this is actually in the middle of the Atlantic Ocean, which actually is a very distinctive example where you'll find examples of diverging plates. Now, students, there are multiple examples of diverging plates, and as you would have we in fact have mentioned in class, this is the North American plate here, which is diverging from the Eurasian plate. You remember we said Europe and Asia is considered to be one plate, right? One massive plate. Well, guess what? The Eurasian plate, all right, which is this side, deviating or diverging from the North American plate. That is one example of a divergent plate boundary. We also have, students, the South American plate diverging from African plate. All right, that's another example. Okay, and we actually in today's class, as a matter of fact, we spoke about the South American plate with respect to the Scotia plate. All right, to give you a better diagrammatic view, this is actually South America here. This is the South American plate, which is encapsulated in not only the continental region, but also part of the ocean as well. And basically, this is the Scotia plate at the bottom here. All right, and they are both basically moving technically away from each other. All right, okay. So students, in summary, divergent plate boundaries are also known as constructive plate boundaries. They move away from each other in opposite direction, as you can see from the image again. Most of the time, you'll find them at below the ocean level or at the bottom of the seabed. They are associated with the formation of volcanoes, that is underwater volcanoes or submarine volcanoes. They are also associated with the formation of volcanic island arcs and also ridges. All right. Just keep that in mind for me, please. There's a distinction between divergent plate boundaries and, of course, convergent plate boundaries. Be sure to understand the difference. If you look at the video with transform plate boundary as well, you can actually compare all three of them and determine what are in fact the differences associated. All right, so feel free to ask any questions. If by chance you have any questions, feel free to let me know. Be sure to look at the video and also at the same time, be sure to revise the work. All right, students, keep it.